Hello, and welcome to Fastener Connect. It is my pleasure to introduce the next presentation. But before I do, please note that we are recording the presentation to make it available to view on demand. We are inviting attendees to write questions into the chat function, from where we will read them out at the end. But now, I will hand over to Thomas Wernitz of the company REYHER, who will be presenting CONU, innovative counter nut with self-locking effect. Over to you, Thomas.
Okay, thank you. Hello and welcome to the next session. My name is Thomas Wernitz. I'm representing the company REYHER, and today I would like to introduce a new product that we are bringing into the market, the CONU, the counter nut. So, as you can see here, there are some examples of that new item, the counter nut. It comes with a message. It comes with a message: flat, safe, and strong. As you can see here, it is not a kind of standard counter nut. I mean, there is no standard counter nut at all. But as you can see here on the countersink surface of that nut, you already can realize that there is some kind of serration, which we know from other locking fasteners that help us to secure the preload of the item in the application. So, what makes that product, the counter nut, so special? First of all, as you can see in the upper right corner, by applying the counter nut together with countersink bolts into countersinks, you can do something pretty unique, which is to achieve a flat surface. You know, usually fasteners somehow, as you can see on the hex nut, somehow rise above the surface of the parts that we have joined. So that is really something that might help together with the counter nut to really sink that item in the parts, due to optical reasons or due to safety relevant reasons that no one might touch the fasteners in case to avoid injuries and stuff like that. As I have presented on the first slide, the special thing about the counter nut is really the design of the nut, which I will talk a little bit deeper later on, and the serration on the countersink surface. And that serration makes the nut safe. So self-loosening is prevented on that item, together with another special design aspect that I will explain later on. That item is really strong, a strong performance in terms of self-loosening. So that really keeps the preload in the application. The serration also comes with another advantage, which is that once the serration is kind of locked into the material, locked into the countersink, you don't need any supporting tool to hold the nut. As maybe many of you know, sometimes if you assemble standard fasteners, it is necessary, if you want to tighten the bolt, to support the nut with a second tool in order to avoid that bolt and nut are turning together. So that is also an advantage for that counter nut. We will later on see that there are two designs for that product, so kind of two types, and those two types allow the use with bolts of strength class 8.8 and 10.9 without any issues. Where does the counter nut come from? As you can see here, the idea somehow came up during a water sport project, like you can see here in the picture. It's a wing foil, and the inventor was somehow challenged with the fact that standard fasteners always kind of stick out of the items you want to fix. So if in that application here, of course, friction and resistance in the water is really critical key fact in order to improve the performance of those wing foils. So it was pretty much like, how can we solve that situation? That I mean, there are countersink bolts, which we know for a long time right now, but often it is not possible to assemble that countersunk bolts into kind of internal thread that has been manufactured into the part. So sometimes it is also necessary to have a standard hole and to use a bolt and a nut. So obviously there was no solution to have also a nut which could be kind of sunk into the parts. So there were a lot of ideas and thinking about that, and final question was that, yeah, how would a nut look like that could be sunk into the part, prevent self-loosening, make the assembly quite easy. And the final result of those thoughts or of those research activities was the CONU. Due to the special design, which I will explain in the next slide a little bit more in detail, and the idea where that product comes from, also all the fields of application have been taken into consideration so that there is a wide range of applications with that product. So as you can see here, composite materials like CFK or something like that, that is not an issue. Of course, standard application with metal parts is also not an issue. The use with wood parts allows some new interesting application. For example, if you think of playgrounds or something like that, usually you see that, I mean, it is very important that if kids go on the playground, that no one is kind of, you know, no one sticks to the fastener. So usually there are a lot of countersunk bolts used, but of course, for the other side of the countersunk bolts, there was no solution so far. So during playground design and construction, people always had to think of a connection that, for example, is done in a way that the countersunk bolt has to be assembled, let's say, towards the kids, so that the kids cannot touch them or stick with them or something like that. And on the other side of the bolt, usually there are still standard nuts used. There then some idea of you know, they're outside of the whole area where the kids are playing. But of course, with a CONU, that design aspect can be changed right now. You don't have to regard anymore how to assemble the fasteners, because both fastening elements, both fasteners are sunk into the material. So that would also help to increase safety on such application a lot. Also, application in plastics is no problem for that. Of course, preload is going to be significantly different compared to metal, but that is pretty clear. So there's a wide range of application and wide range of materials that the CONU can be used with, together with its advantages of being sunk into the parts, showing a flat surface, and also prevent any self-loosening. Where does the product come from? So it was invented by Malte Fürstenberg. That was the guy we saw in the wing foil picture just before. And there are partners, of course, who supported that development, which is REYHER, which is also Nordlock in terms of questions for self-loosening effects. And of course, finally, we got the manufacturer of the first parts that we have here, which is the company HEBI. So also from my side, thank you for the support for those partners. And together with that expert team, let's say from the European fastener industry, we developed that kind of product with those unique advantages, as I've shown before. So that nut has been launched a few days ago, so we are just about to start. So if we look at more design aspects and details to understand how that nut is working and how that nut is, I mean, it's pretty easy to see that obviously nut can be sunk into the material, so that is not as complicated. But to understand also the self-locking mechanism, I would like to explain you some more details on that. So as you can see here in the picture, a key design aspect is the angle of the countersunk of the nut and the angle of the actual countersunken part. So one of the key aspects of that CONU nut is the special design, and the special design is a little bit explained in that slide here. As you can see on the right-hand side, there's difference of the angle of the nut and of the angle of the countersunk. So the angle of the nut is a little bit bigger than the angle of the countersunk. So that means once the nut is assembled into the countersunk, the serration, of course, somehow touches the countersunk, and the diameter where the serration touches the countersunk is quite big because it's at the upper end of the nut, where the serration touches the countersunk. So many people of you maybe know that the bigger diameter is of something that touches during assembly, the higher the resistance to self-loosening. So that's the first big advantage that the nut comes with due to the angle. The second one is the more you preload the nut, the more it will bend into the countersunk. So more area, let's say, more area touches, more area of the nut touches the countersunk. So there's going to be more serration, which comes into effect, which will help, of course, with the self-locking mechanism. And the items are kind of, really kind of stick together, but we know that also from other locking fastener elements or fasteners. And with those two design aspects, so the angle difference, the mechanism of bending during loading, and also the serration, the self-loosening of the joint is really prevented. And then there's another example, or there's another advantage that comes with the fact of the serration, which I explained already a little bit. Of course, since the serration somehow lock into the countersunk, there is no need of any supporting tool anymore. Sometimes you know that if there's, for example, a smaller thread damage or something like that, if you assemble standard hex parts, so let's say hex bolt and hex nut together, and there maybe, of course, since it's mass parts, it's always there's always the possibility of small thread damages, and if you assemble them together, it could happen that if you turn bolt, the bolt is not, or the joint is not tightened, but instead of that, you turn bolt and the nut together. So sometimes you need a supporting tool when turning the bolt, and you need to support the nut to prevent that the nut is turning. And that is something that we don't need here, actually, because the nut locks into the countersunk, and due to that, obviously, it cannot turn together with the bolt or screw that you are using together with that nut. There have been done a lot of tests to ensure that the self-loosening does not happen. So I show you one example here right now. Actually, there have been done 4 different test setups, which means we have done those tests with a high preload, with a medium preload, and with a low preload, because of many of you know that not all locking fasteners have the same performance in all preload levels. So usually you can see that some of locking fasteners show much worse performance if you reduce the preload level, because they simply do not lock as good into the material when the preload is under a certain level. That item has been tested in that 3 preload levels, high, medium, and low. The lowest one was around 5 kilonewton for M8, which is very low preload level for M8 actually. But also in that very low preload level, the item did not show any self-loosening. So it really works under all conditions. There have been also a lot of tests in terms of loadability. As you can see, and maybe also as you know, the design of that item is not a standard one, so you cannot refer to any calculation formula in terms of nut height, hardness, which results in certain loadabilities, means in certain proof loads. So there have been a lot of investigations done, a lot of testing has been done. You can see some of the results that we have done to determine the maximum load for those items. And in the picture, you can already see that there are two versions. You can see the S version and you can see the L version. I will explain that later on. You can compare that to different kind of property classes. So the one is the standard version. The other one is the large version, which has higher strength in terms of loadability and proof load. So all that test that we have done and the investigation result in those two types of the CONU. The first one is the standard one. It's called CONU S. Obviously, it should be used in a counterbore hole, in a countersunk, corresponding to the nominal diameter. So if you have an 8 CONU, you use it in a countersunk according to D74 for M8. Then there is a second type. The second type is the CONU L. It's a larger nut. The nut body is simply a little bigger. The nut body is a little bit higher, and that nut has to be used in a countersunk of the next nominal diameter. So if you are using a CONU M8, then it should be used in a countersunk according to D74 for M10. So with that larger body and with that higher nut body, we achieve much more loadability, so the nut can carry much more load. So what is the performance that we evaluated at the moment? There have been a lot of tests done with those two types, CONU S and CONU L, in the size of M8. You can see here an example on the right-hand side of the CONU used together with the standard ISO 10642 countersunk bolt. Currently, the CONU is manufactured from QT steel with a hardness range of 220 to 300 HV. And with that material and with that hardness, so with that strength, we can achieve a nut design that is able to carry the preload of standard 8.8 bolts. So the maximum load for the CONU S is calculated based on the standard preload, which is calculated based on a 90% yield strength limit, and we use standard friction of 0.14 for the calculation. So the ratio between tensile and torsional stress is given by the thread friction 0.14. Thus, that together with 90% use of yield limit of the bolt results in the investigation if the CONU standard, the CONU S, is able to carry that load. And yes, it is able. So it is not a problem to use that nut together with 8.8 fasteners and to fully preload the bolt. The nut is able to withstand that. And if you look at one detail, which is the nut height for the CONU S, which is only 0.6 times diameter, you can see that there has been a lot of research done to optimize the design of the nut, because usually 0.6 times diameter items or nuts are not really able to carry the full loads of 8.8 bolts. If you want to go higher in terms of property classes or in terms of load, then you will need to use the CONU large. With a larger nut body and with a higher nut height, those items or those nuts are able to withstand proof load requirements for class 10. So in that case, not only the preload of class 10.9 can be carried by the nut, also the full proof load requirement of class 10 can be fulfilled. There's one thing you have to be aware of, and that does not refer to the nut actually. Actually, that refers to the bolt. As you know, all bolts have incomplete thread at the end. That incomplete thread makes sense in terms of it's easier to assemble the bolt into internal thread. But of course, that incomplete thread does not carry. That incomplete thread is not able to carry any load, or it's really not able, but it's able to carry significant lower load limits. So if you want to achieve the full loadability of the nut, it is important that the incomplete thread needs to go beyond the nut body. So you have to assemble it in a way that no incomplete thread is remaining in the nut body. So you can have full loadability between the bolt and the nut. As a conclusion, I would like to emphasize some key facts about the CONU. First of all, of course, in terms of productivity, the nut enables quick assembly. You just put it into the countersink, start assembling the bolt. There's no supporting tool needed because the nut is fixing itself in the hole. Of course, due to the design, there are no additional locking fasteners needed because the nut is already self-locking, which helps in many applications. In terms of efficiency, of course, the nut is able to provide that self-locking purpose in a wide range of applications for dynamic loads. So usually thinking that countersunk applications are quite complicated in terms of securing them against self-loosening. That item provides a solution right now that comes really with the advantage that we have the self-locking effect in some countersunk application, and therefore we prevent self-losing. As you've seen before, there's a wide range of materials that item can be used with, so that enables also a wide range of different application. Due to the countersunk design, you can also use that item for center aligning purposes. So if you want to align the center of something of your parts, the nut will also help to do that due to the countersunk design. Yeah, and finally, there's also some optical, some design aspects for that item. We can achieve a flat surface by sinking not only the bolt, which we have done many years or many decades right now with countersunk items, but we can also sink the nut into the part, thus resulting in completely flat surfaces, although they are joined by fasteners, which is also a pretty neat thing about that items. In the design phase of that project, we've optimized the types for maximum load capacity. So on the one hand, the standard one for 8.8 preload level, and the large one for 10.9 for using with 10.9 loads. Yeah, due to the fact that there are many new things, of course, on that item, there is product patent which is currently pending, will be coming soon. Okay, so thank you very much. I hope you enjoyed the session. You got an idea about that brand new product which just entered the market that offers a wide range of new applications. Comes with some pretty neat things like that countersunk design, self-locking design. So thank you very much for watching this, and I'd be happy to answer questions.
Thank you very much. We did have a few questions coming in. First question, what surface coating does CONU have?
Well, thank you. That's a very good question. At the moment, as you've seen, that item is manufactured from QT steel 220 to 300 HV, so it is kind of standard carbon steel for nuts, and currently the items are coated with a zinc nickel coating, 5 microns, that comes up together with a passivation of around sole screw resistance 480 hours, so it also allows the exterior application in the environment with a pretty good lifetime.
Thank you. Next question. What materials are available at the moment for this nut?
Yeah, thank you also for that question. Currently, there are items for, let's say, testing purposes available from standard carbon steel, but there is also a wide range of materials possible if you have some special applications that require maybe higher corrosion resistance. Of course, stainless steel grades would be no problem for that product. So if someone has any special applications for that, please let us know, and we will analyze the application and come up with a proposal of the most suitable material for that, which is no problem at all.
Thank you very much. We have also got a poll with a question for the audience. For which branches of industry do you see possible uses for CONU? Just publish this poll. But marine, furniture construction, mechanical plant engineering, vehicles, rail transport, or others. You can vote in this poll now. Well, we've got 16% for marine, 16% furniture construction. Oh, it's changing. Let me give it another minute. So 12% for marine, 40% furniture construction, 20% mechanical and plant engineering, 10% for vehicles, 9% for rail transport, and then 9% others. Thank you very much. And one more poll is CONU of interest to your company? A 100% yes. That sounds good. Very good. Very good end to the session. And this marks the end of this session. Thank you very much to our presenter and to all of you for watching. Goodbye.
Okay, bye.